So let's solve question number 11. In the question number 11, they have said a train moves up an inclined track. So you can say this is an inclined track, and from here a train has been moving up with a constant velocity. So the velocity is constant. This is a really important information. The train moves through a vertical height of 25 meters. So the vertical height is 25 meters. This is the vertical height, which is 25 meters. So that the gravitational potential energy gained by the train is about 400 millijoule. So they have asked us to find out the gravitational potential energy. Mass of train has been given. So let's go and find it out. We know the formula of gravitational potential energy. The formula of GP is mass into gravity into height. They have given us the mass which is 1.7 into 10 to the power 6 into the gravity, which is 9.81, into the height 25 meter. The overall answer will be 4.17 into 10 to the power 8 joule. So we're done with 8. Moving forward to the question number B. In the question they have said the train engine has an output power of 20 megajoule. Okay, the thing is they have said us to show it in 400 megajoules. So we know that 400 megajoules means 400 into 10 to the power 6. Mega means 10 to the power 6. So we can write it down as 420 into 10 to the power 6 joule to make it in this way, to show that in megajoule form. So in question number B, they have said has an output power of 20 megawatt. The train takes 35 seconds to move through the vertical height of 25 meter. So it takes around 25 seconds to move from this position to this position. So we know the formula of power is work done divided by time. We know power is equals to work done by time. So work done will be power into time, which is 20 into 10 to the power 6 into 35, which will be equals to 7.00 into 10 to the power 8 joule. And we all know this was the energy. This is the energy that was gained by the train. So this was the energy gained, and this was the work that the train has done while moving up. This was the overall energy, the overall work that the train has done, but it has gained only this amount of energy. So the other rest of the energies has been invested because of the resistive forces. The resistive forces has taken up those energies. So we have to just subtract this value from this overall work done to get the work done by the engine against the resistive forces like friction or any other resistive force. So let's find it on work done against resistive forces will be equals to 7 into 10 to the power 8 minus 420 into 10 to the power 6. The answer will be 2.83 into 10 to the power 8. The reason behind subtracting this value from this value, subtracting this value from this value is this was the overall work done by the car moving up the ladder or moving up the inclined track, and this was the energy that the car gained. So the rest of the energies has been invested because of the resistive forces. The rest of the work done was done against the resistive forces. So the rest of the work will be 7 into 10 to the power 8 minus this. You can also use you should actually use not this. You should actually use this value, which we found out here, 4.17 into 10 to the power 8, because that's the actual value, and that is how you show the answer. So we are done with this answer, and let's move forward to the question number 12. So let's solve the question number 12. They have said an iceberg is a large mass of ice that floats in seawater with most of its volume below the surface of the seawater. So the thing is this iceberg is floating into the water. This iceberg is floating into the water, and its most of its part is below the surface of the water. So an iceberg can be modeled as a rectangular block of ice. A particular iceberg has a 6.7 meter of its total height below the surface of the water. So out of its overall height, just 6.7 is into the surface of water. Okay, so let's move forward to the question and see what they have asked us to do. In the question part, they have said the block of ice has a horizontal cross-sectional area. This is our cross-sectional area. They have asked us to find the weight of the block of ice. They have asked us to find the weight of the block of ice. We all know the weight of the fluid displaced is equals to weight of block of ice. So the weight of block of ice will be weight of fluid displaced is equals to rho Vg, and the formula is volume of the fluid. We also know the volume of the fluid is equals to the volume of the solid or the volume of the blocks. So we can also write it as the volume of solid as well. You can also write it as the volume of solid into G. So the formula will be the density is given 1.03 into 10 to the power 3 into the volume, which we have to find out. The volume will be this cross-sectional area into the height, which was given as 6.7. As we know, the formula of volume is cross-sectional area into height, which is 6.7 is equals to, the value will be 2.35 into 10 to the power 4 into the G, our gravity. So the answer will be equal to 2.37 into 10 to the power 8 Newton. And the reason of the weight of fluid displaced being equal to the weight of fluid of ice will be, I think you guys have confusion in that thing, right? So I am going to show you one demonstration so that you guys can understand it to a much better extent. The thing that is happening right here is, so let's say we have taken a beaker of water. There is water in this beaker. This is the volume initial, and I have just immersed a ball into this fluid. So as I have immersed this ball into this beaker of fluid, there was previously a lot of water in these parts, right? As the ball has been immersed into this, the volume of this ball has displaced some of the liquid into this direction, right? Some of the liquids into this direction, and in this direction. It has displaced a couple of liquids. So we can say the volume of fluid displaced is equals to volume of this solid. This solid will displace the same volume of liquids as its volume. The volume it has will be the same as the volume it will displace. So we have written the volume of fluid is equal to the volume of solid. The volume of fluid displaced is equal to volume of the solid. So another thing that I want to mention is weight of the fluid displaced and the weight of the block of ice. Don't you guys think that as the water level was in this position before, when I have immersed this ball into this beaker, the water level of the fluid has increased, the water level has risen. So there is a change in volume of the water, and the water that has risen is because some of the water has been displaced. So we can say the weight of the fluid displaced, is equal to the weight of the ice. This block of ice has a weight which is around, suppose, 10 newton, and it will also displace 10 newton weight of fluid from this position. So we can say weight of fluid displaced is equal to weight of block of ice. So that is the reason why I have just make you guys understand, because it's a really perplexing situation, because a lot of students make problem while understanding this. So let's go back to the question. They have said an identical block of ice floats in water of a lower density than the sea water in a large volume of this block is below the surface of the water. So what they have said is, we can say the weight of the block equals to the weight of the fluid displaced. We will just mention this part right here as well. The weight of the block is equal to the weight of the fluid displaced. And we all know, as the ball has been immersed into the beaker, the ball has its own weight, right? And there is an upthrust force acting on the ball upward. There is an upthrust force acting on the ball upward. As the ball is in equilibrium, the upthrust must equal to the weight. Upthrust is equal to the weight. So we can also say the weight of fluid displaced is equal to the weight of the block. The weight of fluid displaced is also known as the upthrust as well. Weight of the fluid displaced can also be said as upthrust. Don't need to write this thing, you can just write that thing, but I have just mentioned it because so that you guys can understand. So if we consider this formula and look at this, they have said a lower density. If the density decreases, the volume will increase, right? Because the density and the volume are inversely proportional. So they have said a larger volume of this block is below the surface of water. So it's quite obvious that as the density is lower, the volume will increase. So we have to just mention at equilibrium, the second point will be at equilibrium, the density of seawater is inversely proportional to volume of water displaced. This is the equation which we can use to interpret that thing. So we are done with question number 12 as well. 13, in the question number 13, they have said two cars A and B are racing along a track. So car A and B are racing along a track. They have said car A has a constant velocity of 13 meter per second, which is a really important information, that it has a constant velocity. When anything has a constant velocity, its acceleration is zero, right? Its acceleration is not increasing or decreasing, so its acceleration is zero. At a particular instant, car A is 9 meter ahead of car B as shown. So car A is 9 meter ahead. It's also very important information. At this instant, car B has a velocity. So it has a velocity of 93. It doesn't has a constant velocity. So it must have an acceleration. Car B is accelerating with a constant acceleration of 14 meter per second square. So it also has an acceleration. So it didn't have, the car A doesn't have any acceleration, but car B has an acceleration. So in the question part, they have said, show that the car A and car B are side by side after a time of about 1.1 seconds. So say after 1.1 seconds, they have said the car A and B are side by side. So being side by side means they are in the same position. So after 1.1 seconds, they have said if it is 1.2 second, we have to show it. So the car are side by side. So they had a displacement, right? From this position to this position. The displacement of car B was equals to the displacement of car A, as their displacement is similar here. At this position at this position both of them have the same displacement. At this position both of them have the same displacement, that is why they are side by side. So we can say car A S is equals to car B S, that their displacements are equal. So here car A was already 9 meter ahead of car B. Car A is already 9 meters ahead of car B. The 9 meter is added to car A's equation. Now we will add 9 meter to car A's equation. We can write the displacement of car A as, we know it has an initial velocity of 93. So we can say 93 into time. We can say ut. The formula of displacement is ut, right? Speed is equals to distance divided by time. So the displacement will be speed into time. So this was the speed and the time we have to find out, plus this 9 meter. We have to add 9 meter, and in terms of car B it has a velocity and it also has an acceleration. We will use the formula S is equals to ut plus half at squared, which will be 93t plus half into 14t squared. And the reason behind using this 9 meter in this displacement is because the 9 meter is added to car A's equation, because the problem states that at a particular instant being considered, at this particular instant car A is 9 meters ahead of car B. That's why at a particular instant we have added this 9 meter. This 9 meter represents the initial head start that car A has over car B. Since car B is behind by 9 meter at that instant car B is 9 meters behind. Its displacement equation does not need that additional 9 meters. Instead car B's displacement starts from where it is. Its displacement starts from here. So we have only done with this. Now we have to just make t the subject of this equation and answer this question and find the time. So we can write it down as 9 meters is equals to half into 14t squared. There is 93t and here is 93t. We can remove these two. So we are left with t is equals to root over 9 divided by half into 14. So the answer will be 1.13 ms minus 1. We are done. The reason behind adding this 9 meter is because the car A is 9 meters ahead of car B. The car B starts from the displacement, and the car B starts from displacement, but car A starts from displacement plus 9 meter. And after 1.1 seconds they both end up in the same side by side position, so their displacements are equal. So we are done with in B. In 13b they have said at the instant shown car A is 100 meter from the finishing line. So car A is right here and it is 100 meter away from the finishing line. So what they have asked is, deduce whether car A reaches the finishing line before car B. So the time taken for car A should be less than the time taken for the car B. For the car A to reach the finish line before car B, right? The time of car A should be less than the time of car B. In such a way, the car A will be able to reach the finishing line before car B. So let's go and find the time of both of them. So to find the time A, it is really easy because it was moving. We know speed is equals to distance divided by time. As its speed was constant velocity of 93 and its time was, we need to find, and the distance was 100 meter. So what we have to do right now is, the time will be found out using this 100 of the distance divided by the speed. The time of A will be 1.075 seconds. Right now what we have to do right now is to find out time of B. time of the car B. Finding of the time of car B will be a bit difficult because the car B didn't have constant velocity, it has acceleration. Car B had acceleration, so we have to use the formula S is equals to ut plus half at squared, where we know the displacement is 109 meters. The reason behind the displacement being 109 meter is because the car B was already behind car A by 9 meter, and it also need to cover another 100 meter from car A's position to the finishing line, which is from car B's position to the finishing line. It's 9 meter here and 100 meter here, so overall displacement is 109 meter. We can write it down as 109 meter. The initial velocity was 93 into time of B into the time of B plus half into the acceleration was 14 into time of B squared. Now we have to use we can find this using the formula minus B plus minus B square minus 4AC minus 93 plus 93 squared minus 4 into 14 by 2 into minus 109. I'm not showing all the workings because you guys, I hope you guys can complete it by yourself because it's just a normal math problem. So the time here comes is 1.084 seconds. So this time is greater than this time, so it's true that car A will finish first, as this time is less. So time A, so the time A is less than time B, so the car A will finish first. So we are done with question number 14. In the question number 14, they have said a grain of sand quickly reaches terminal velocity when it falls into water. So you can say that this is a tube where there are water and the grain of sand is falling into the water. So it has reached terminal velocity. So terminal velocity means its forces are balanced. Terminal velocity means its forces are balanced. So when does its forces gets balanced? When a sand was falling into the water, okay, so it has a weight, it has an upthrust force, and it also has a drag force upward. So we can say when the forces are balanced, we can say the weight is equals to the upthrust plus this drag. So we can say the weight of the grain is equal to the sum of the drag and upthrust acting on it. So we are done with 14A. In the 14B, they have said a spherical grain of sand has a weight of 4.3. The grain of sand displaces water with a weight of this. So we know weight of fluid displaced we know weight of fluid displaced is equals to upthrust, right? So we can say this part is our upthrust and this is our weight. So we know when the sand was going downward, it has a weight, it has a upthrust, and it also has a drag force acting on it. That is our drag. So there is two forces upward and a force downward. The terminal velocity of the grain sand as it falls through the water is this. So it has reached a terminal velocity. So they have said whether Stokes law applies to the grain of sand, as is we have asked to be deduced that whether Stokes law can be applied to this. They have given us the viscosity and this diagram. So we all know for the Stokes law to apply, we know the formula of Stokes law is viscous drag is equals to 6 pi r eta v. So we have all the things except the drag force. We have to find out the drag force. We know weight is equals to upthrust plus drag. So we have got this weight, we have got this upthrust, we have to just find out this drag using weight is equals to upthrust plus drag. So we have the weight, which is 4.3 into 10 to the power minus 5 minus this upthrust, which is 1.5 into 10 to the power minus 5 is our drag. So the drag will be equal to 2.8 into 10 to the power minus 5. So now we can use this formula of drag. Drag can now be used in this part and used to find out this velocity, whether this velocity matches with this terminal velocity of 0.05. So what we can do is v is equals to 2.8 into 10 to the power minus 5 divided by 6 into pi into diameter has been given. We have to just find out the diameter. We have to find out the radius. 1.5 into 10 to the power minus 3 divided by 2 into the eta value, which is 1.2 into 10 to the power minus 3. So we are done with this. The velocity of the value of velocity is equals to 1.65, which is not equal to this value, which is not equal to 0.050. So we can conclude, so Stokes law doesn't apply. And moving forward to the question number C, they have said explain why the temperature of the water affects the terminal velocity if Stokes law does apply. So we all know drag is equals to 6 pi r eta v. So if the temperature increases, we can say, we know when the temperature increases, the viscosity decreases. So if this viscosity constant gets decreased, then this terminal velocity increases. If the viscosity decreases, the terminal velocity will increase because it has an inverse relationship. So we can say so the terminal velocity increases to make drag equal to the weight, because this drag needs to be equal to the weight. This drag needs to be equal to this weight. So we are done with question number 14. Alright, so let's solve question number 15. In 15, they have said two identical balls A and B collide. Ball B is initially at rest, so its initial velocity is 0. After the collision, ball B moves off in the same direction as ball A. So they are moving in the same direction. The initial velocity of ball A is 0.739. After collision, the ball B is 0.691. So the velocity of ball A immediately after the collision is 0.5. So we have been asked to find out the velocity of ball A after the collision, and we have to show that if it is 0.05 or not. So let's go and find it out. If you consider before collision, we know the conservation of momentum says momentum before collision before is equals to after. So we can say momentum is equals to mass into velocity. Momentum is equals to mass into velocity. So for ball A, the momentum, both of them has this mass 0.065. We can say 0.165 into this velocity for ball A, 0.739 is equals to, we will not consider the ball B before because the ball B had a 0 velocity, so its momentum was 0 as well. So for ball A, after the collision, it will be this velocity 0.165 into VA plus for ball B it will be the mass 0.165 into the velocity V, this 0.691. So I have to make this velocity the subject and find out, which is V is equals to 0.122 minus 0.114 divided by 0.165. So the answer will be 0.048 ms minus 1. So this is basically our answer, 0.048 ms minus 1. So let's move forward and answer question number B. In the question number B, they have said before the collision the kinetic energy was this and the kinetic energy was 0. Determine the decrease in total kinetic energy during the collision. So initially the total kinetic energy was this, because ball B didn't have any kinetic energy. So we have to find out the final kinetic energy and then subtract the final kinetic energy and initial kinetic energy to get the decrease in total kinetic energy. So to find the final kinetic energy, we can find for ball A, final kinetic energy is equals to 0.5 into mass 0.165 into V square. The final velocity was 0.048. So we can say 0.048 squared. The answer will be 1.9 into 10 to the power minus 4 joule. And for B, final kinetic energy was half into 0.165 into its final velocity, which was 0.691 given on the question paper, is equals to 3.94 into 10 to the power minus 2 joule. So we can add these two to get the total final kinetic energy. Total final kinetic energy is equals to 1.9 into 10 to the power minus 4 plus this value 3.94 into 10 to the power minus 2, which is equals to 3.96 into 10 to the power minus 2 joule. So it was the initial and it's the final. So the difference will be, so decrease in kinetic energy will be 4.5 into 10 to the power minus 2 minus this value, which is 3.96 into 10 to the power minus 2. The answer will be 5.4 into 10 to the power minus 3 joule. 5.40 into 10 to the power minus 3 joule. As the questions are in 3 significant figure, we have to give the answer in 3 significant figure, which is 5.40 into 10 to the power minus 3 joule. So in the question number C, they have said during the collision there is a resultant force on the ball B from ball A. Actually the thing is the ball B was stationary and the ball A was approaching towards it, and after the collision absolutely the ball A will collide with it and ball A will have a force on ball B on this direction, and in the same way the ball B will have equal and opposite force on ball A. This is Newton's third law, right? The ball A is exerting a force on ball B and the ball B will exert the same equal and opposite force on ball A. So the ball A was accelerating at the first as it has a resultant force in this position, but as ball B is exerting a force on ball A on this direction, so the ball A will decelerate now. because the net force before was on the right direction, and now there is also a force in the opposite direction to its motion, so it will decelerate. We can say it will decelerate, and the ball B will accelerate in this position because the ball B doesn't have any other force on any other direction. It has only a force on the right, so the ball B will only accelerate, but ball A will decelerate because previously it had a acceleration in the right direction. But as ball B is exerting equal and opposite force on ball A according to Newton's third law, and the ball A now also has a force on the opposite direction to its motion, so it will decelerate now. So we can just go and write it down. The question was, during the collision there is a resultant force on B, the ball B, the resultant force is on the right from ball A. Explain in terms of Newton's law why the ball A decelerates. The ball A decelerates because by Newton's third law we can say, by Newton's third law, ball B exerts an equal and opposite force on ball A. This is our point number 1. We have to give 2 points as the question is 2 marks. And the point number 2 will be by Newton's first law, resultant force on A causes the ball to decelerate. So we are done with question number 15 as well. So let's solve question number 16. They have said a student carried out an experiment to determine the Young modulus of copper. So we have to find the Young modulus. The experiment is to determine the Young modulus. The student clamped one end of copper wire to the bench. So there is the clamp where the copper wire was clamped. This is the clamp. This is the wire which was clamped on one end. The wire passed over a pulley and masses were added to the other end of the wire. So there is a wire which was passed through this pulley, and there are some weights attached to it. So a meter rule was there. There was a meter rule. There was 1, 2, 3, 4, 5 readings. Let's say there was this kind of readings. And the thing is, a marker was attached to the wire as well. So when the masses were added, the marker will move from this position to this position. So the marker will move. So we'll be able to find out how much the marker has moved. So this way we'll be able to find out the extension of the copper wire. As the copper wire will extend because of these masses, we'll be able to find out the length of the extension of the copper wire from its original position, and through this we will be able to find out the strain. Okay, so these are all the things. Moving forward, we can say they have said the student measured the diameter of the copper wire. The diameter has been measured. Now the question is, describe other experiments that need to be made using this apparatus and how they will use to determine the Young modulus of copper. First of all, the thing that we have to do is we have to find out the original length from the clamp. The original length from the clamp to this marker. We have to find out this length. This is the original length. And after that, we have to measure the distance moved by this marker when the masses were added. And after measuring this, we'll be able to find out the strain. The extension is, this is the extension and this is the original length. So extension divided by original length gives us our strain. Now we have to also find out the weight of these masses as well. We have to find out the weight of these masses. The weight of these masses will be the force, and we know force per unit area is our stress. So force per unit area, and area will be found out by using the diameter which we have been given. So this is how we will be able to find out. And after finding the stress and strain, we can use those stress strain values to find out the Young modulus. So just they have given us 6 points. We have to write all those points, all those into 6 points, and add as more informations as possible to get the whole 6 marks. So let's move forward and write it. We will start by writing the first point. Measure the original length from clamp to marker. This is the original length from the clamp to the marker, which we have to find out. And then later on, after the masses will be added, this marker will move into this position. Let's say it has moved into this position. This is the extension of the copper wire, which we have to also calculate. We have to mark that as well. So we will write measure the distance moved by marker from original position to determine the extension. And after that, the third number point will be we have to calculate the weight of these masses. We know weight is equals to mass into gravity. And the fourth point will be we have to use this diameter to calculate the cross-sectional area. To use this diameter to calculate the cross-sectional area. We're done with 4 points. Now we have to find the stress and the strain. Calculate the stress using force per unit, force by area. We have found out the weight. This is our force and this is our cross-sectional area. We will use it to find the stress. And strain using this original length and this extension, using extension by original length. So we are done with 5 points. Then the last point will be calculate the Young modulus using stress divided by stress divided by strain, which we have found out. So we are done with 6 points, and we have to memorize these 6 points because this is a really repetitive question which might arrive in our exam day as well, and it's a very common question, and the mark scheme is the latest mark scheme, May 2024. So I will love to see October 2024 candidates memorize this whole 6 points so that you guys can answer this type of questions very easily. And kindly memorize all the other experiments as well, because you never know, in your exam day maybe another experiment might arrive. So in the question number B, they have given us the weight which was attached to the copper wire, and the diameter has been given. We can use the diameter to find out the cross-sectional area. So let's find out the cross-sectional area first. The area will be pi r square, which is pi into 0.56 divided by 2 squared, which will be equal to 2.46 into 10 to the power minus 7 meters squared. This is our area, and the force has been given, so we can find out the stress straight away. The stress will be 5 divided by 2.46 into 10 to the power minus 7, which will be equal to 2.03 into 10 to the power 7 Pascal. So now we have to find out the strain. For the strain, for the value of strain, they have given us the Young modulus, so we can use it to find out the strain. So the strain will be equal to stress by Young modulus, which will be 2.03 into 10 to the power 7 divided by this value, which is 1.1 into 10 to the power 11. The strain will be equal to 1.85 into 10 to the power minus 4. As we have got this strain, now we can find out the extension as the length is given. So del x will be equal to 1.85 into 10 to the power minus 4 into the length, which is 2.5, and the answer will be 4.61 into 10 to the power minus 4 meter. So we are done with question number 16.
Hi guys, assalamu alaikum. Today we will solve a projectile motion question from the year May 2024. This is a projectile motion question which came in the year May 2024. Question number 17. So let's start solving. So they have said a child is playing a game. The child is trying to get stones to land outside an old tire floating on the water. So basically the thing is the child is just trying to get this ball onto this tire by launching it in the air. He wants it to land in between this tire which is flowing in the water. A child throws a stone at a speed of 6.3 and at an angle of 50 degrees to the horizontal. The speed was 6.3 meter per second at an angle of 55 degree. The stone leaves the child's head at a height of 1.5 meter above the surface of the water. So this height is 1.25 meter above the surface of the water to which it will fall. So in the question they have asked us in this question they have said show that the vertical component of the stone's initial velocity is about 5 meter and that the horizontal component is 4 meter. Okay, so basically they have asked us to find out the horizontal and vertical component of the stone which he is launching. Okay, so the thing is it was launched at 6.3 meter per second. So it will have it, as it was launched at an angle, it will definitely have a vertical component and a horizontal component. This is the horizontal component and this is the vertical component. So we all know as the horizontal component is within the angle, so it will be 6.3 into cos 55 degree, and as the vertical component is without the angle, it will be 6.3 into sin 55 degree. Sin comes when it is without the angle and cos comes when it is with the angle. So let's find out. 6.3 into sin 55 degree is equal to, this is for the vertical component, and for the horizontal component 6.3 into cos 55 degree. So the answers will be 5.16 ms minus 1 and it will be 3.61 ms minus 1. Actually it was a kid stuff, nothing else. Okay, so in question number B they have said show that the greatest height above the surface of the water reached by the stone is about 3.5 meter. We all know as the stone is launched in the air, it will reach a height. After reaching that height, it will again come down. So they have asked us this maximum height which this ball will reach after it was launched from 1.25 meter above the surface of the water. So let's find out. We will use the formula v square equal to u square plus 2as in order to find out the greatest height. In order to find out this greatest height, we will use this formula: v square is equal to u square plus 2as. So we all know, as the ball will reach its maximum height here, and after then it will again come down. So here his velocity will be 0. His final velocity is going to be 0. And as the ball is moving in the vertical direction, as we are counting the vertical height, we will take the vertical velocity, which we found out here, 5.16 ms minus 1. So the final velocity will be 0, and the initial velocity will be this velocity, as it was the vertical component. We are finding out the vertical height of the ball, or the vertical height of the stone. So we will take this velocity, neither this 6.3 nor this 3.61. We just take the vertical velocity, which will be 5.16 ms minus 1 plus 2 into 9.81 into the s. As the ball is going upward, and we are only concerned about the upward motion of the ball, we are taking the acceleration as positive. If we have taken the downward, if we considered downward motion of the ball, we have taken the acceleration minus g. When we take upward motion, we take positive g. And when the motion involves both positive and negative, both upward and downward, then we also take minus g. So this is a basic that I wanted to clear for you guys, that this is a really important thing, because a lot of students get stuck in these small basic problems which make them lose marks. Because if we have put here minus 9.81 other than the real 9.81, then we would have lost the mark, and the whole math would have been wrong. We would have made problems in number C as well. So doing the right things right here is really important. So let's do it. So in order to find out the S, we have to do if we square this 5.16 centimeter square, which will be 26.6 m square s minus 2, divided by this 2 into 9.81 becomes 19.6. So the displacement is 13.6 meter. Sorry, 1.36 meter. It will be 1.36 meter above this height. It will be 1.36 meter above this height. This is the 1.36 meter. But we have been asked to find out the surface of the water, above the surface of the water. So we have to take this 1.25 into consideration as well. This is the height from which the ball was released, or the ball was launched. But we have just found out the height of the ball after it was released from this 1.25 above the surface of the water. So we have to add this 1.25 as well. 1.36 plus 1.25 becomes 2.61 meter above the surface of the water. So let's move to the question number C right now, as we are already done with question number A and B. Let's move forward to the question number C. So the question number C, they have said us to find out. They have said, what they have given us, the inside of the tire is 0.8 meter. Okay, so they have said the diameter of the tire is 39 meter from the side of the water. So the distance is given as 3.9 meter. This is the distance, which is 3.9 meter, and this is 0.8 meter. Okay, deduce whether the stone thrown by the child land inside the tire. So they have asked us to find out whether this stone will land into this tire, or it will fall short, or it will go further away from the tire. So in order to find that thing, it's usual that we have to find out the horizontal displacement of the stone. If we find the horizontal displacement of the stone, then we will be able to easily be able to find out where it landed. If it is within 3.9 meter, then it will land here. If it is between 3.9 and 0.8, means if it lands with, if the horizontal displacement is within 4.7 meter, then it will land here. And if it is greater than 4.7 meter, then it will land here. And if it is less than 3.9 or equal to 3.9, it will land in here. So let's find the horizontal displacement of the horizontal displacement of the ball. So to find out the horizontal displacement, we all know velocity is equal to displacement. Sorry, 1 minute. We all know velocity is equal to displacement divided by time. So here we have to find out the horizontal displacement. So we have the horizontal velocity, right, which we found out there. This was the horizontal component of the velocity, which was 3.16 meter. This is the 3.16 meter, which we will use right now because we are finding about the horizontal displacement. So we have the horizontal velocity, which is 3.61, and we have to find out this displacement, but we don't have this time. So in order to find out the horizontal displacement, now we have to find out the time taken for the motion. So let's find out the time taken for the motion right now, for the whole motion. So in order to find out the time of the whole motion, we know we will be following the formula V is equal to U plus AT. This is the formula we will use. So we all know that the initial velocity of the vertical component was 5.16 ms minus 1 into minus 9.81 into time. But we don't know the final velocity of the vertical component. We don't know the final velocity of the vertical motion. We know the initial velocity of the vertical motion, which we found out here, 5.16, but we don't know the we don't know the we don't know the final velocity of the vertical component. So let's find out the final velocity of the vertical motion. So in order to find out the vertical motion, we can use v square equal to u square plus 2as. So here we can take v square equal to, we can root over this. We know the initial velocity, which was 5.16 squared plus 2 into, as we are taking right now the double motion, so the acceleration will be minus 9.81. Like I make you understand previously that when we take double motion, upward and downward motion, we take negative g. When we only take the upward motion, we take positive 9.81. When we only take negative, when we only take downward motion, we take minus 9.81. So here it is upward and also downward, so we have to take 2 into minus 9.81. And we all know the the displacement, which is minus 1.25 meter. Okay, so the answer of the velocity will be minus 7.15 ms minus 1. As we right now know the final velocity minus 7.15, now we can put this right here. Minus 7.15. So right now we can find out the time, which will be minus 7.15 divided by the time will be 1.25 seconds. So this is the time for the whole motion. So now we know the time, we have to just find out the displacement. So we can plot as divided by 1.25 seconds, which will be multiplied here, and then we will be able to find out the displacement, which will be 3.61 into 1.25. The answer will be 4.51. So as we all know, the horizontal displacement of this position is 3.9 meter, and here is 0.8. So for the ball to reach this tire, it has to be greater than 3.9 meter and less than 3.9 plus 0.8, which will be 4.7 meter. So it has to be between 3.9 and 4.7. As it is 4.51, so it is between that displacement period. So the ball lands in the tire. You can write it here that 3.9 is greater than stone is greater than 3.9 and less than 4.7. So the ball lands in the tire. Hopefully you guys understood this math. So another thing that I want to announce is that we are starting question paper solving lecture videos, a question paper solving course for the October 2024 candidates, and a crash course for January 2025 candidates, where we will revise the syllabus and thoroughly solve all the recent question papers from January 2020 to May 2024. So if you guys want to ameliorate your marks just before the exam and excel in the exam, kindly do message us in our Facebook page, Edexcel Exam Essentials. You can have a free demo class with us, where we will let you know the way we will move forward to get a better result and bring out the best out of you guys. And you can also do a demo class under me, where I will solve a question paper for you. So if you want to join me, then let me know in the comment section, or you can message me in my Facebook page, Edexcel Exam Essentials. Have a good day, guys. Bye. So let's solve question number 18. A lorry is crossing a bridge. The bridge is supported by two columns. This is the first column and this is the second column. Okay. Forces P and Q acts on the bridge from the column. This is the force P and this is the force Q acting from the columns, which is situated on the two sides of the bridge. The center of gravity of the bridge is at its center. This is the weight of the bridge, where the center of gravity of the bridge acts. At a particular time, the lorry is 35 meter from point X, and this is that part when the lorry is 35 meter from the point X. They have set a simplified graph showing the position of the force on the bridge is shown below. Okay. Moving into the question, they have said calculate the magnitudes of forces P and Q. They have asked us to find out the magnitude of forces P and Q. They have given the force from lorry and the weight of the bridge, which is 4.2. This is 4.2. And the weight of the bridge is 9.8 into 10 to the power 5. So what they have asked us to find is
the magnitude of force P and force Q. And the thing is, this point X is going to be our pivot. This point X is going to be our pivot. So let's find out the total clockwise moment and the total anti-clockwise moment. We know that total clockwise moment is equals to total anti-clockwise moment. So we can write total clockwise moment is equals to total anti-clockwise moment. Okay, so here the clockwise moments are, as this is the pivot, from this position these two is acting here. So the force from lorry and the force from bridge are our total clockwise moment. So we have been giving the force, and the distance has been given as 35, and the distance of the weight of the bridge is 35 plus this 25, which is 60. So we can take 4.2 into 10 to the power 5 into this 35 meter plus this 9.8 into 10 to the power 5 into this 35 plus 25, because it is right here, you can say it as 60, is equals to this total clockwise moment. The total clockwise moment is this position, this, because it is acting here, in here, this is acting in this direction. So the force is Q into the distance is this 60 meter and this overall 60 meter, which is 120. So we can use this formula to find out the Q. So the Q will be equals to 6.12 into 10 to the power 5. I'm not doing all the workings because you guys know how to do those workings, because now you guys are in AS physics. So we have done finding the Q. Now we have to find out the P. If you look more closely into this question, we can see that these two forces are acting downward and these two forces are acting upward. So as the forces are in equilibrium, as the bridge is in equilibrium, these two downward force must be equal to these two upward forces. So these two downward forces was this and this. These two must be equal to force P and Q. We have the force Q, so we have to find the force P. So first of all, we have to add these two values. What we will do is 4.2 into 10 to the power 5 plus 9.8 into 10 to the power 5 is equals to something which will be minus by this Q, which is 6.12 into 10 to the power 5 is equals to 7.88 into 10 to the power 5. Actually the thing is, the force on P plus Q is equals to force from lorry plus the force from bridge. So if we found this, we have to find Q. We have just added the force from lorry plus bridge and subtracted the value of Q from that to find out this P. We have just subtracted this from here. So we are done with question number A. So let's move forward to the question number B right now. In the question number B, they have said, explain why force Q increases as the lorry moves across the bridge. Explain why the force Q increases as the lorry moves across the bridge. So the thing happening right here is, they have asked why this force Q increases as the lorry has moved to the right. So the force from lorry was right here. So if it has moved, suppose in this position, the force from lorry will be here. So if the point X was one pivot, so the distance from point X to the lorry has increased. Distance from X to the center of gravity of this lorry. The center of the gravity of this lorry from the point X has increased because it was previously here and it is now here. So the distance has increased. So we know moment, total moment, we can say total moment is equals to moment about X, or moment about this X plus moment about this position can be regarded as Y, this position, because it is force Q can be regarded as Y and P can be regarded as X. So the total moment is equals to moment X plus moment Y, and we all know the total moment will be equal to 0 as they are in equilibrium. The total moment will be 0. So as this distance has increased, as the lorry has moved to the right, this distance, the center of gravity of the lorry from the point A, the distance has increased. So we can say moment about X is force into distance. So as this distance has increased, this force will also increase and the moment about X will also increase. So if the moment about X increases, this is because of 1 minute. This was our point P, moment about P, moment about Q. So as the moment about P has increased because of the distance increasing, as the distance has increased, the moment about P will also increase. So the moment about Q must also increase so that the total moment is equals to 0. So we can say the force into distance. So as the distance of this from this has decreased, the moment about Q, the force must increase a lot so that this is equals to this and overall the value is 0. So I think you guys have understood it. We can write it down in our own words right now. The answer will be this is center of gravity of lorry increases. So moment about X due to force of lorry increases. The sum of moment as it is an equilibrium. So the moment about X due to Q increases. As the moment about Q increases, distance from X to Q
remains the same. Therefore, the Q increases. If I make you guys understand again this thing, if I have to repeat the thing again, the thing that has happened here is this is a very difficult thing to understand, and you have to understand it by heart so that you guys don't get stuck in any kind of moment questions in your exam day. The thing is, the lorry has moved in this position. So as the lorry has moved from this position to this position, previously it has a distance of this distance from the point X, but now it has a distance of this from point X. The point X, the moment has increased. We know the whole system is in equilibrium. So when it is in equilibrium, the total moment is equals to 0. So when the total moment is equals to 0, when the total moment is 0, we can say total moment is equals to lorry. The moment from lorry will increase as force into distance. This distance has increased. The moment from lorry will also increase. As the moment from lorry increases, the moment from Q must also increase. Moment from Q also increases. As moment from lorry increases, as the moment from lorry increases in this direction, the moment from Q must also increase in direction, so that the equilibrium is 0, because they are in opposite directions, right? They are in opposite directions. So as the moment from lorry has increased, the moment from Q also, the moment from Q must also increase, so that the total moment is 0. As it is in equilibrium, total moment needs to be 0. So as from moment from Q needs to increase, the distance of Q from point X is constant, right? So we can say force into distance. The distance is constant, so the force must increase, so that the moment of Q increases. Moment from Q increases. The moment from Q must increase because the moment from lorry has increased. And to keep the bridge in equilibrium, as the moment from lorry has increased, because the distance of the lorry from the point X has increased, the moment of lorry has increased. And the moment of lorry has increased, the moment of Q must increase, because it has to be in equilibrium. As they are in opposite direction, the moment from Q must increase. So for the moment from Q to increase, the distance is constant, but the force now need to increase, so the Q increases. So we have just answered that in this part. So we're done with question number 18. Right, so let's solve question number 19 right now. The question number 19, they have said a zip line consists of a cable fixed at 2 points. This is a cable which is fixed at this point and this point. The person hangs from a wire attached to a wheel. This is a wheel. The wheel can move along the cable. The wheel is movable along the cable. The wheel moves the person along the wheel. As the wheel moves along the cable, the person also moves. In the position, the person is accelerating. Complete the free body force diagram to show the 3 forces acting on the person in this position. So we have to show the forces that is acting on the person. So as the person is attached to the wire, there must be a tension force acting on the wire, and there is also a weight acting, and there is a resistive. As the person is accelerating in this position, there must be a air resistance acting on the opposite direction. So these are the 3 forces that is acting on the person. So let's go and write down. This is the air resistance, that is acting on the person, and this is the force from the wire, that is acting on the person, and there must be a weight acting. These are the 3 forces that is acting on the
person. So let's move forward to the question number B. In the question number B, they have said at particular instant the tension in the cable is 200 Newton. The angle formed by the cable at the wheel is 144, diagram as shown. So the tension in the cable in the cable and the angle formed by the cable at the wheel, tension of the cable at the wheel, these are two extended by 144 degree. Tension forces on the cable given as 1200 newtons at two angles, both 144 degree apart. So to find the resultant force acting on the wheel, we can use the two force at an angle formula. The formula of two force at an angle is, there is two force at an angle and we have to find the force on the wheel. So two force at an angle, the formula is The formula is 2t into cos theta by 2. So the 2t is 2 into 1400 into cos 144 divided by 2. The answer will be 741.6 Newton. So we are done with question number B. Moving forward to the question number 2, they have said there is a force on the wheel from the wire of 800 Newton. There is a force on the wheel from the wire. So actually this was our wheel. They have said the force on the wheel from the wire. So there is a force in this position to the wheel from the wire. So the force will be in this direction. Force on the wheel from the wire. And another thing that they have mentioned is, the direction will be downward as the force is on the wheel from the wire. So the force will be downward. The force on the wheel from this wire. The wire is exerting the force. So the force on the wheel will be downward as the wheel is downward. And another force that is acting is the angle between the force from the cable and the 800 Newton, which is the force from the wire, is 150 degree. So the force from the cable. So we have to find out the force from the cable as well. And the force on the cable will be in this direction, as this is the cable. So we have to add a vector diagram right now. We have to find a vector diagram. They have said the angle between the force from the cable is 800 Newton and the force from the wire is 1. We have found the force from the cable previously. We have found the force from the cable. This is the force from the cable. Force from the cable on the wheel. So we can use a vector diagram to find out. We know the force from wire is 800 Newton and the force from the cable that we have found out previously was 742 Newton. So we have to find the magnitude of the resultant force. So we can use a vector diagram to find that out. What we can do is, for 800 Newton we can take 8 centimeter, and for 740 Newton we can take 7.42 centimeter, and to draw these two into a vector triangle to find out the resultant force. If we draw freehand right now, if this is 8 centimeter, which is downward, the force force from wire and this is another force from the cable, which will be taken as 7.42 centimeter. Then we have to find and calculate this distance. Sorry, I have just drawn it. You have to just find the distance of this, and if we calculate it through a ruler, then it will come as 3.9 centimeter to 4.00 centimeter. So we can say the resultant force will be 390 to 400 Newton. It's just a matter of doing some ruler work. You have to just calculate the distance of this using a ruler and draw these two lines using 8 centimeter and 7.42 centimeter. So we're done up to this. Then let's move forward to the next question, next part of the question. The next part of the question, they have said people take turns at moving from zip line from high point to the low point. The people initiate rest at high point. Explain why the speed of people with different masses are always about the same when they reach the low point. Why the speeds of people with different masses are always about the same. So the speeds are always same no matter what the masses are. This is what the question is. So let's move forward to the question and see what they have said. What they have said is when they move from this high point to this low point, no matter what the mass of this person is, they always end up with the same speed. So why is this happening? Why the speed is not why the speed is not dependent on the mass? Why the speed is not dependent on the mass? The thing is, here the person has a GP, right? The gravitational potential energy, and right here this gravitational potential energy is transferred into kinetic energy. So if we write down, the GP is converted to the kinetic energy. So let's go and write it down in our page. We can say GP is equals to kinetic energy. GP is mass into gravity into height is equals to half mv squared, which is transferred. So if we remove this mass, the velocity only depend upon 2gh. So the velocity is independent of mass. We can say velocity is independent of masses, as the velocity doesn't depend on the masses. It only depends upon the height because the g is also constant. It only depends on h. And this was our point number 1, this overall. And the point number 2 is this GP is converted to kinetic energy. We have to also we will also have to say that most E grav transferred to as high point to low point as the person move from high point to low point. In both the equations. And another thing is there is no resistive forces. Work done against resistive forces are negligible. So we are done. The first point was the velocity doesn't depend upon the masses, it only depends on the h. And the other point was most of the gravitational potential energy transferred to the kinetic energy and the mass in both equations. You can write either this point or this point for the number 2. As this has 3 points, you have to write 3 points. As this has given 3 marks, you have to write 3 points. whether either this or this. And the third point will be, we haven't taken the resistive forces into account. We're just talking about negligible resistive forces. So we are done with this question and this paper.